Okay, so good day to our grade 8 Mahaki Science High School students. Let's continue solving problems in circles. But this time, this is going to be a new lesson. This is going to be our 6th lesson on circles. Now we're on sector and segment areas of circles. Okay, so let's try to solve and jump right ahead into this problem. Find the area of a segment if its central angle measures 60 degrees and the radius of the circle is 12. So first, we need to illustrate the problem. First, let's draw a circle. It doesn't have to be a perfect circle. So this one is an imperfect circle. Okay, so let's try to draw a point here. Let's say that this is point A. And it says here that its central angle measures 60 degrees. Okay, so if its central angle measures, let's say for example, 60 degrees. Okay, and the radius of the circle is equal to 12. So what we want to find is the measurement of this area. So let's try to shade that. Okay, if we're going to shade that, so this is the area that we want to find for this problem, this green shaded part. So what's the area of this green shaded part here? There you go. How do we solve for the area of the green shaded part? Okay, so to solve this problem, we have to recall the formula for finding the area of a circle and the area for finding the formula for finding the area of an isosceles triangle. Since this is a circle, what's the formula for finding the area of a circle? So that's pi r squared, right? And since we're only taking a fraction of the area of the circle, we need to get the central angle, which is symbolized or represented by theta, all over the total angle measurement of a circle, which is 360 degrees, and multiply that. So this part would be the area of the sector of the circle. And then we have to get the area of the triangle. We formed the triangle here, but it's not just a regular triangle, so it's an isosceles triangle. So why is it an isosceles triangle? If you look closely, we have two segments here. We have the radius, which is equal to 12, and another line segment. Now this line segment is equal to this line segment, so therefore this would also be 12. And therefore, to get the area of an isosceles triangle, that's just 1/2 for the basis of this problem. Since we're solving circles, it should be 1/2 r squared, or the square of the radius of the circle, times sine of theta, okay? Or the value of our central angle for this problem. And again, this is going to be the area of the isosceles triangle. Okay, and now we're prepared, or we can now solve for the area of our segment. Okay, so let's try to solve. So the area of the segment is just going to be equal to 60 all over 360 multiplied by pi times 12 squared, okay, minus 1/2 of the value of, again, the radius. So that's 12 squared multiplied by sine of 60, or central angle. So this is going to give us 60 over 360. So that's 1/6, right? 60 over 360, that's just 1/6. Okay, 1/6 of 144 pi minus 1/2. Okay, so 12 squared is 144, so we can write here 144 over 2 multiplied by sine 60. Okay, so let's try to simplify this problem. So we have 144 pi all over 6, okay? And then we have minus 144 sine of 60 divided by 2. Okay, and it's 144 over 6. So that should give us 24. So this is going to give us 24 pi minus, okay, 144 divided by 2. So that's just 72. So that's 72. Yeah, so that's 72 sine of 60. And what's 72 sine of 60? Well, the sine of 60 So that's equal to, if you tried to use the unit circle before, so that's gonna give us the square root of 3 over 2. Okay. And if this is the square root of 3 over 2, so this is gonna give us 24 pi minus 72 multiplied by the square root of 3 over 2. And this should give us 24 pi minus, so what's 72 divided by 2? So that's 36. So minus 36 square root of 3. Okay, and if we try to evaluate that, so therefore the area of the segment is just equal to 24 pi minus 36 square root of 3. And that should give us 24 pi minus 36 square root of 3. So it should give us this decimal value. So that's around 13.04 squared units. So therefore the area of the green segment, using our formulas for finding the area of a sector and the area of the isosceles triangle. So there you go. The area is approximately 13.04 squared units, or exactly 24 pi minus 36 square root of 3 units. And that's how we solve this problem.